Hello there, and welcome back to another C# intermediate tutorial with the Stride game engine. In this tutorial, we'll learn about rigid bodies and specifically collision triggers. By the end of this tutorial, we'll have a scene similar like this. We have a sphere falling down due to gravity and a rigid body, and if we press space, we reposition it or teleport it back into the air. And then we have this green transparent box that our sphere will roll through, and we're going to display some text in the air if there is a collision and whether the ball has entered and exited this collision trigger. As you can see, I have opened up the Start Collisions Trigger scene, which you can find under Scenes, Collision Triggers, and then the Start Collisions Trigger scene. This scene only contains the default scenery, a camera, and this ramp where our sphere will bounce off from. Let's first add our sphere to the scene. We're going to go to the Models folder in the Solution Explorer, and if we scroll down, we have this nicely prepared stride ball or this procedural model that we can drag into our scene. Let's drag it simply upwards. And now we're going to add a rigid body component, which is one of the components that comes with the Stride game engine. And rigid bodies, they make sure that objects fall down by gravity, that they interact with other objects that have rigid bodies connected to them as well. And here we can set various properties related to physics behavior. Like for instance, by default, every rigid body will fall down due to its mass setting. Every rigid body also requires a collider shape for it to work properly. Now, since this is a very basic geometric model of a ball, all we need to do is click Add on this plus icon here, and we can add a sphere. Now you may notice nothing really changes in our viewport, but if we wanted to see what is actually going on the physics side, and we wanted to debug the collider shapes, then we can go up here to this Grid and Gizmo options icon, and if we click that and we navigate down a little bit, we have this physics checkbox here. And if we click that, you'll see some lines or wireframe outlines appearing in our scene. We see these red outlines, which means that we're dealing with static colliders for our geometry around us. But if we move into our sphere here, we will see those yellow outlines, which is just the object that we have selected, which I can deselect with this option right here. And this green wireframe that we're seeing here, that means that we have a rigid body and a collider shape attached to this model. So we know that this size of this collider shape of a sphere is actually the correct size, and it's encapsulating that sphere model properly. So if we would start this game, let's see if everything's working the way we want it to work. If we click Start and go to Collision Trigger, then our ball will start falling down due to gravity, and then it will just roll towards the end of the level. Now let's create a script that if we press space, that it will be teleported somewhere up here again, and so that we can reset our test scenario for the collision trigger. Let's create a new entity called Teleporter. And that's going to be our starting location for where our ball is going to be spawned towards to. So we need to position it slightly above the ramp, like so. It doesn't have to be the exact same location as the sphere, but this will do for now. So once we press space, that's what we're going to do in a script. The ball, wherever it is, it's going to fly back or being transported or teleported back to the location of this teleporter. So let's create that script right now. Let's go back to our Solution Explorer. Let's go to Collision Triggers, and here we're going to create a new script, a sync script to be exact. And let's call this Teleporter Sphere, since the teleport itself is already used for the completed scene, and we want to start from scratch. That has been saved. And now let's go to Visual Studio and start typing. Here we have our teleporter sphere script. Let's open that and let's add a public variable here of type entity, and we're going to link in our sphere. So we'll be adding this script to our teleporter, and then we can reference that sphere by dragging in the sphere to this property in our property grid. We don't need to do anything inside the start of our script, but what we are going to do is we're going to say if input dot is key pressed, if our space key is pressed, then we want to do something. So first things first, sphere transform dot position. We want to update the position of the sphere to the position of our teleporter. Now at the moment, our teleporter has the exact same local coordinates in comparison to the global coordinates. So if we would be using world matrix dot translation vector, which is the world position, that is currently similar to the entity transform dot position, since it's the first layer of our scene hierarchy. For good measure, let's just use the world matrix dot translation vector, and we're good to go. Then we say sphere dot transform, and we say update world matrix. You always want to do this when you're manually updating the position, especially if you're using that translation vector or the world position. Right now, if we would start our game, we would position our object at the teleporter location, but there's a slight catch. Because the physics engine that we're using is still thinking, hey, our rigid body is still at that old location where it was rolling on the floor somewhere. So we need to specifically say to our rigid body that that has been updated as well. So I'm going to say, let's make a variable here called rigid body, and then on that sphere that we've made, we can say sphere get rigid body component, which by default isn't included yet with the namespaces. So with Alt Enter, we can say using stride.physics. That's where that component resides. And now we have retrieved the rigid body component from our sphere. Now, the first thing that we need to do is cancel out the linear velocity, because when you think about it, our sphere is rolling on the floor and it's, well, rolling around its own axis. It has a certain momentum. And that means that if we would spawn back our ball at the back of this teleporter, it still has that momentum. So we need to stop that or cancel that out. So I'm going to say new vector 3, nothing between the parentheses, which means that it's similar to this value or these 3 values, which simply means there is no momentum for this sphere. And then finally, we say rigid body update physics transformation. So keep that in mind every time you have some sort of script and you want to update the position of an entity that has a rigid body and you want to update that manually, like the way we are doing right now, then always call this update physics transformation method. Let's save our script. Let's go back to the editor. And then here on our teleporter, all we need to do now is say teleporter sphere. This is the one we just made. And that's the one that already existed for the completed scene. And now all we have to do is link in this sphere. I called it stride ball. And if we run our game, and if we start loading that collision trigger scene, our ball is still falling, but if we press space, our sphere will neatly teleport back into the air and it will start falling again without it causing any kind of weird issue. So again, if we would leave out that resetting of the linear velocity and our ball would be rolling and we would be teleporting, then it wouldn't fall straight down. It would move somewhat to the right, like it's being thrown into the scene. Now let's add our collision trigger to our scene. For that, we're going to go to Models and drag in this box 2 by 1 by 1. I'm going to rotate that slightly. I'm also going to give it a different material so that it looks a little bit more like a collision trigger. So I'm going to use this transparent material that I can find in the materials folder. Let's also scale up this collision box just a little bit. There we go. And now let's go to Components and add the Static Collider, which is quite similar than a rigid body, with the only difference that it's a static physics object. It stays still in our scene. It doesn't fall to the ground, so that means it's not being affected by gravity, but a lot of the properties, just like with this rigid body, still apply. So if we open this up, notice how we have a lot less options than with the rigid body. We do still need to set the collider shape, so let's click on Add, and this time we click on Box. As we've seen before, there are these red boxes in our scene when we have the physics debugging disabled, and notice how this box is slightly too small, so we're just going to scale that up a bit, and now it's encompassing our collision trigger box. Now right now, if we would start our scene, our sphere would start rolling, but then it would bump into this box and then it would stop rolling. That's not what we want. We do want our ball to pass through our collision box, and in code, we still want to see the collision events happening. We can simply do that by going to this property here in the static collider, which is called isTrigger. You can find this option on rigid body components as well. Notice that our red box has now changed to this purple outlined box, indicating that it is a trigger. Let's also rename our box to something more suitable, like collision trigger. Now we go to our code folder and add another script, which is going to be collision trigger. Select our collision trigger entity and add the collision trigger script that we've just made. Now we can start coding. Now let's first reference that static collider component in our script. It's not available by default, so we need to include stride.physics namespace. We can then say collider is entity get static collider component. Now that we've retrieved the collider component, let's have a look at the first way of checking what kind of collisions are currently occurring and that we can do something with those collisions. Let's make a for each loop. And in this for each loop, we're going to say collider.collisions. If we hover over this collisions property, we can see that we have some sort of list, in this case called a tracking hash set of active collisions that are currently happening with our collider. Now, for the sake of this tutorial, we'll only have at max one collision. When the sphere is not rolling through our collision trigger, no collisions are happening with our collision trigger box. However, as soon as the ball passes through it, this for each loop will go one time because there is only one collision happening at the moment. But in your scenario, you might have multiple collisions happening at the same time when multiple objects are passing through this collision trigger. For now, we're just going to go assume that there's only one collision at max, so we're going to say debug text print, and let's print out the name of the first collider object. So we say collider A is collision.collider A, and then the entity that this collider belongs to, and then let's print out its name. Let's display that somewhere nice on the screen. And then let's copy this line, and right below it, let's display the name of Collider B. Now let's run the code that we've just created. Let's pick the collision trigger scene. And now as soon as the ball rolls through our collision box, we will have some text being displayed on screen. And as soon as the ball is no longer rolling through the collision trigger box, there is no text drawn to the scene. One more time. Notice how Collider A is stride ball, and Collider B is the collision trigger itself. Okay, so far so good. We have seen one way that we can deal with the collisions that are currently occurring with this static collider component. Now let's have a look at another way of dealing with collision and collision events. We can say collider.collisions and then collection changed. This is an event that is automatically triggered as soon as there are colliders either added or removed from the collision collection of this collider. Now we can use tab to generate the method for us. I'm going to enter so that we accept the name that we currently have. And then we have these two parameters. First off, there is the object that has triggered this collection change. And then second, we have this tracking collection changed event argument. Now to make use of that, let's first make a new variable called collision, which is e.item. And we have to cast this to a collision. So this argument contains all kinds of information about what kind of collision just occurred and why this particular method is being invoked. Now we need a way to make sure which of the colliders that this collision exists out of is actually the ball collider. So we're going to make a variable called ball collider. And in order to determine this, we're going to compare the actual collider component. If that is equal to the collision dot collider A, if they're the same, then we know that the other collider is actually the ball collider. And if that's not the case, then it's going to be collider A. Now let's do a check. We can have a look at the argument action. And we can compare that to what kind of action has occurred with this collision. If it's an add action, let's also remove the additional namespace here and include it so that we have a little shorter if statement. So once again, if the action is an add action, then we know that the ball collider has entered our static collider. So we could store the status of what is actually happening in a string. Private string collision status. By default, that's empty. Let's store that into this if statement. Collision status, and we're going to say that the ball collider dot entity dot name has entered the, and we could say plus collider dot entity dot name. So it's completely dynamic right now. And a pretty much similar thing can also be done with another action, which is the remove action. That means that if the ball collider would exit our collision trigger, the event arguments for this method would be that the action is a remove action. And in that case, our ball collider has exited our static collider. Let's also display this onto our screen. So we're going to say debug text dot print, and we're going to say collision, that collision status. Let's print that to the screen. Let's display this on x500 and this time 360 as the y coordinate. Now let's give our scene one more spin. So at first we will be seeing no text at all, but as soon as our ball enters the collision trigger, it will say our sphere has entered the collision trigger, and as soon as it leaves, it will display that on the scene as well, that it has exited the collision trigger. Stride ball entered, and stride ball has exited the collision trigger. One more time. Stride ball has entered the collision trigger, and stride ball has exited the collision trigger.